Hi, hello. As Bill has just introduced me, I am Dr. Rossi. I teach organic chemistry at Roger Williams, I am the current chair also of the department. And I've been here for about 10 years. I have enjoyed being right on, not only at campus, but with the colleagues and with the students that have come through my classes, but also that are able to do a lot of research with me. And so that's really, I think, something that is not just building within our department, but also something that's throughout the entire campus. And so when you're able to come on campus, and I highly encourage you to stop in and see not only the campus itself, but also the M&S building and the chemistry department. All right.
As we get started, I just want to remind everybody, if you have any questions, if you put your cursor over the main screen, right over the PowerPoint, you'll notice at the bottom a menu screen will pop up. Questions in this kind of event probably best come in the form of the chat function. If you just click on that, you'll have a standard chat screen that will come up, and we will answer your questions as you ask them.
Great, great, thank you. Okay, so here is some pictures that we have about the department, right? So we are a department of chemistry as well as physics, and we have a lot of students that are involved. Not only that are majors, but are involved in the chemistry that we do, the science that we study. And so this is just to show you all the different aspects that we have and have offered. We have hands-on experiences that the students are actually doing the research, right? And then we have a number of other experiences throughout their time here that we encourage all of our students to really get engaged with and to participate in. And this is just some sort of snippets of images that show that, right? That allow us to have that. Okay, so let's go through a little bit about what the department is about, what we have to offer. All right, and so just to sort of give you a quick overview of the department and where it sort of fits in at Roger Williams. There are a number of schools that we have at Roger Williams. And so that was something that's really sort of unique about our university, is that we have, right, it's a school of law. We have a number of other schools that are right within that university. And we have the social and natural sciences. That's where we're sort of located. That's where we fit in, if you will. There's overall 7 schools on the campus at Bristol. And what's really very, I think, very unique to the university and our students is that they are able to not be just in one school. They're able to take classes and able to have majors and minors in other schools. So you could have a major in the business, or you could have them as well as in the natural sciences. And so it's really a nice, a unique atmosphere that encourages that. We have a lot of double majors. A number of majors are between chemistry and biology, but we've had some also between marketing and chemistry, and other ones as well, so that it sort of allows that breadth of interest to be fostered. We do have that integration between those professional schools and the sciences, and so it's something that we encourage as well as facilitate along the way. Okay. So this is the actual building that hopefully you'll be able to walk yourselves into at some point. This is the Marine and Natural Sciences. This is where all the physical and natural sciences are located. We have the Department of Chemistry and Physics, which is what I'm going to be talking about today. We also have the Department of Biology, Marine Biology, and Environmental Science. And so that's also housed within this building, and Mathematics. And so we're all within this one building, and to get a sense of what happens when you walk in, it's a clover-shaped kind of building. And so on one side is where the faculty offices are, on the other side is where, on the left is where your classrooms are, and straight ahead is where all the laboratories are. And so we're really centrally located so that if you're in the laboratory, you can easily talk to someone as a faculty member right sort of next door. And then you also have the classes right there too. So we have that sort of arrangement that works really well for us, whether it's research related or classes related. Okay. These are the different members of our department. Right? So we have a number of different chemists as well as physicists within the department. And so we're pretty evenly distributed between the women and the men, which is sort of a unique aspect of these types of departments. Most of the time they're not as distributed as we have them. We have inorganic chemists, physical chemists, environmental, as well as biochemists, analytical. And so these are all the different subdisciplines of chemistry. And so when you figure out or when you find out what kind of interest you have, not just in general chemistry, but in a certain aspect of it, we have someone there that can help you sort of guide you towards what you may want to do after Roger Williams, or where you might want to do it as a career, or what other classes you might want to take, or what research opportunities you want to be looking at. And so we have all these great aspects to it, so we can advise you very well. We also have two physicists, one that's a biophysicist and another one that's more astronomy based, and so they also are going to be able to help you if that's your interest too. Okay. So what are our options? What do we offer? So in chemistry itself, that we offer both a Bachelor of Arts as well as a Bachelor of Science. That's in either chemistry or environmental chemistry. We do have those two tracks. Besides that, we also have the Bachelor of Science in biochemistry. And so that's a little bit different than chemistry or environmental chemistry, as that you can imagine. Some of you may have the interest in receiving or pursuing that biochemistry degree. But those are the three that we have within the chemistry aspects. All the Bachelor of Science degrees that we offer are certified by the American Chemical Society. That is a very large society that reviews our program I believe it's every 5 years. And what they do is they check to make sure that our curriculum matches up with the standards throughout the country. And within that, we also require 400 lab hours after general chemistry. And so that ensures that you have the skill set and the experience within the laboratory, which is very important for chemists, as you can imagine. And so that allows us to be able to make sure that when you leave Roger Williams, you are able to not only say that you have the bachelor's degree, but that also you have the experience, and that the ACS certification qualifies that, right? Beyond that, we also have the the 3+4 pre-pharmacy program. That is a program that has been set up with the Albany College of Pharmacy up in Vermont. That's the Vermont campus. And so that's really sort of a unique experience to have as an undergraduate, right? A primary undergraduate university. I can talk a little bit more about that in a little bit later, but we also offer that. There is also a Bachelor of Science in Forensic Science. That there's two different tracks for that Bachelor of Science. There's the chemistry and there's the bio track. The chemistry track is within the School of Justice Studies itself, but we have a number of classes that are within that track. And so that's also maybe of interest to you. That's what we offer. And then this is our first year, which we're very excited about, is to have the Bachelor of Science in Physics. And so that's a new program, and it's been coming out through the curriculum that there's an interest for it. So we're very excited to be able to finally offer that now. And so if you have any questions about that, we can also talk about that or chat about that as well. All right, so those are the different offerings that we have within our department. So let's first talk about that pre-pharmacy program, because some of you may have that interest. So within this dual degree program, what is done is that you spend the first 3 years sort of in an accelerated track, if you will, here at Roger Williams. So you're doing a number of the different courses that would be necessary for the Bachelor of Science. either the Bachelor of Science or the Bachelor of Arts, I should say, right? Either one. And you do that first 3 years here at Roger Williams. And then at that 3rd year, you would apply to the Albany College of Pharmacy. And that 4th year, you would be doing all your classwork at Albany in Vermont, at the Albany College of Pharmacy in Vermont, but it would also count at the same time for your Roger Williams degree. So that 1 year would count for both. What we have with this agreement is that we have 10 spaces for admissions. And so they have entrance requirements for this program. And so that would be something that you would apply for. And they have those 10 spaces for us to place our students into. There's an interview and writing assessment and PCAT exam that still need to be done, as would be for any pharmacy program that you would be interested in. But that would be it gives you 1 less year to have to worry about any sort of bills or paying or whatnot. So it's very appealing, right? 1 less year of paying is always a good thing, right? And so that was what would be happening. 90 credits would be here, and then that 4th year would be counting towards both. Okay. All right, so let's look at some of the courses that we would take, whether it's a biochem degree or your chemistry degree. So you would start off with taking your general chemistry. Typically, that's your first year, Gen Chem 1 and 2. And then the 2nd year, you would be taking organic chemistry and analytical and instrumental. Those are the common classes in your sophomore year. And if you are interested in taking or pursuing the Bachelor of Science or the Bachelor of Arts in Environmental Chemistry, you would also be taking your Environmental Chem in 1, probably in that sophomore year instead of the Analytical and Instrumental. But it would depend really on what your interests are and what you're pursuing. Then your junior year, you would be taking the inorganic and the biochemistry sequence, as well as the physical and the advanced class would be your senior year most commonly. But what that also does with having that spaced out within your years here, it allows you fairly easily to have a double major, which is really appealing to a lot of persons. But also it gives you a lot of time for that one sort of thing that really a lot of us have interest in doing, right? Is getting those chemistry hands, those chemists' hands, and that's doing research. And so this allows this sort of timing throughout the semesters, throughout your years here, gives you a lot of time to be able to do that research. And so you would be actually in the lab, which I hope sometime you do actually come down to see Roger Williams, the labs that we have. You would go in the labs and you would actually see where you would be doing the research. And so that's one of the key attractive aspects of Roger Williams chemistry, is that you are in the lab, right? You're doing your research project with the mentor, right? With that faculty mentor. Sometimes it could be your own project that you might have an interest in, or it could be an ancillary project off of one of the faculty members. It's all different sort of things that you can work on. And so that's really something that's unique. Throughout your classes, you have built the skill set and the experience on the instruments themselves. We don't have teaching assistants. We don't have postdocs to run the different instruments or maintain them. We're working on them ourselves, and you're learning how to use them yourselves. And so that's really very valuable experience, whether you're going on to graduate school or you're going on to some career in industry as well. So beyond that, the majors require the physics 1 and 2, and calculus 1 and 2, which is pretty standard for a bachelor's in chemistry, whether it's environmental chemistry, or biochemistry. One other aspect here that I didn't mention is that there's also an additional advanced course that you need to take. That advanced course can be whatever it is that your interest is within, right? So let's say you really have an interest in physical chemistry. So we offer an advanced physical chemistry, and usually you would take that, right, in your senior year. advanced organic, right? So that would be also the class that you would take as that advanced elective, usually in your senior year. So we do have those advanced classes that would be offered, I believe it's every other year for those advanced ones. Okay. Physics, for those of you that may have an interest in the new major that we have. So we have a number of physics courses that are regularly taught every semester. Those are the intro physics 1 and 2, as well, whether it's calculus-based or algebra-based. And for the Bachelor of Science, you would take the calculus-based. For the Bachelor of Arts, it would be the algebra-based. And they also provide research opportunities for undergraduates as well. So we encourage you, if that's something that's of interest, we can sort of get in contact with a physicist so that you can ask more questions about that as well. Other courses that are based upon the interests of our physics faculty are listed here as well, right? Astronomy, biophysics, and other classes though as well that are really sort of interesting that really feed into that Bachelor of Science in Physics. So this is probably, right, where you see yourself that helps distinguish yourself from others within the department when you're as an undergraduate, but also as you start thinking about where you're going to be going and what you're going to be doing after Roger Williams. And so that's really where student research comes into play. And it's really something that we encourage, we engage with our students. It is faculty mentored, but it is student driven. So that means we'll help you along the way, but we really want you to sort of to be doing it, right? To learn those skill sets from us to be able to do that. So we have funding. We do funding for different research projects. And so you get practice with writing proposals and seeing what sort of things need to go into those proposals to be successful, what things are unnecessary. And they have summer research opportunities. So students are supported through the Summer Scholars Program often. And so they have different programs on campus. One summer we had up to 36 students there doing research projects with various faculty members within the department. We've even had some also over winter into session if, you know, summer sessions don't work out well for some persons with their timing and where they live. We also have those opportunities as well. And so these are some examples of some pictures here that show some of the students that are actually doing the research, that are actually getting their hands, right, wet, if you will. So we have, this is Jenna Lowe. She was working with a high altitude balloon. And so she was studying with Dr. Adria Updike in physics about different sort of components within that. This lower here is a picture within the laboratory. This is Lisa Feely. She worked with me as a undergraduate. She's now at the University of Alabama, and she's pursuing her graduate degree, her doctorate degree there. And so she was working on, this is called a rotary evaporator. And so she was working on doing some synthesis of some organic compounds. But just as other examples, this is Amanda McCabe. She's also working with Dr. Murphy as a physical chemist. Travis Correa, who was working with Dr. Timpson, right, with electrochemistry and inorganic compounds. This is Hannah Nolte, who was actually a marine bio major, right? We're not just restricted to chemistry majors, right? So we have marine bio majors that are doing research with us. So we're not, we're not just chemistry Pearsons only, right? We try and expand. And if you have an interest in doing different projects, we open our doors for that, right? So you don't have to be limited to just being a chem major to work with us. So there's Hannah Nolte, who was a Bachelor of Science in Marine Bio, and she was working with Dr. Breen as an analytical chemist, and Jordan Brown, who also was, he actually was a forensic science major. And so he was interested in determining different, the threshold of detection for certain molecules. So we have all these different projects that, you're not limited to just having a chem degree to work with, but that also allows us as faculty members to get to know different students in different classes coming from different perspectives. And it's a very sort of encouraging type of environment. And it also really allows a lot of collaboration. You're able to come in with your own perspectives and what you're offering a unique perspective to each of those products, which we encourage and we really enjoy. After doing some research, often what we're able to do, which is really very unique, I think, to Roger Williams, is that we have you go and present your work, right? And so we have you working at national and regional conferences. You present research posters, right? You're not just at a national meeting in some little small area where it's just undergraduates presenting. You're often presenting in the same location as some graduate students or some postdocs. And so you're presenting work and you're able to sort of have that same presentation skill, that same confidence in what you're presenting because you did the work and you know how it works best. And you're able to provide your analysis of your data. And so you're able to not only stand your ground, if you will, but you're actually really showcasing how strong of a background you receive from Roger Williams. And so at these different conferences, whether they're regional or national, you're either presenting a poster or you're presenting a research talk, and you're also able to job network. We've had persons like Holly Eberlin here who presented at a national conference, and she was able to present her work alongside other graduate programs and graduate students and other postdocs, and was able to have an offer for a grad program saying, please, come have an interest in this graduate program, apply to it. We've had others as well that have went and worked with career centers at these national conferences, and were able to sort of secure interviews for different positions as well. So there's a lot of things that we can do by having you go to these national conferences, not just to promote Roger Williams, but also to promote what you do, and the type of background that you receive from Roger Williams really helps you and puts you on a good footing for that. Okay. And so this is some of the students. And so we try and capture some sort of image from the different national conferences that we've gone to. So we went in March of 2019, we went to Orlando. And so these are some of the students that were able to, we received an award for the student affiliates there. And that's what's shown here in that top picture. And the lower picture is also where we went in 2018. These are the students that went there, and they went to in New Orleans. And so those are those two pictures. Unfortunately, we don't have one for this particular year. The conference itself was canceled. It was in Philadelphia. And so we did have students planning on going there, but travel plans have been affected for that. So we'll have, I suppose, a gap in our trend here, but we all, I think, understand why that may be. Okay, and so through the student affiliates, we have really the social network of chemists and students that really like and get excited about chemistry. And so we have different well-known speakers come onto campus, and they're able to give lectures. And so we take our students to dinner with them and have those type of conversations with them and pick their brains about what's going on in their particular subdiscipline, their research area. We do community outreach programs. We go into the local high schools and we talk about chemistry, we talk about science, and we talk about, to this particularly the elementary school and to those type of schools, those students that really are interested in it, but that yet haven't really been able to have that much exposure to it. And so we're able to go into those communities as well and do that kind of work. And we also have social activities too. We have different things that we do as fun as well. So we have different gatherings on campus that help to build community amongst the scientists, not just the chemists. Okay. So some of the students are able to go to lunch or go to dinner with different speakers that we invite onto campus. So some speakers that we've had have included Nobel laureates as well as Priestley Medal recipients as well. And we invite them to campus and they give a lecture that is to the undergraduates, to the entire community as well. And what we are able to do is have the students have an interaction with these type of really renowned scientists, and which is really unique for undergraduate university. I should note that this Distinguished Seminar Series is actually put forth and sponsored by an alumni. And so after the Gagliardi's family have endowed a seminar series because of the type of experience that their son received at Roger Williams. And so they were so happy with what they were able to, what happened with their son, to be able to then give back and bring these type of high caliber scientists back onto campus to give a talk. And so this is where this endowed seminar series originated from that idea, from that alumni. So the Gagliardis have also brought in, besides those two last persons, they've also brought in other persons that are scientists, but that relate to other disciplines. So for example, we had Sam Keene, who was a writer, right? And so he was, came on campus, talked about what was really interesting about science and what got him interested in writing about science. But he's actually technically a writer, right? And so we had hosted him with the Department of Writing Studies and Rhetoric and Composition. So we were able to sort of reach out to these other departments to invite these speakers. And even more recently, we had reached out with the Department of History, and we were able to bring Joe Hersey, who is was actually an archivist at the American History Museum in the Smithsonian. And so he was able to talk about development of beer, right, within the United States and how it's impacted different drinking habits and immigration and whatnot. And so sort of looking at those studies and about the chemistry of beer, right, and how it's important, but also how that with the composition of the beer itself and how it's made really has a ties into the history that's ongoing in the at that time period. So it was a really very interesting talk that sort of related historical context to the chemistry that they were studying. So it was very cool. And so those type of seminars and interests help to show that we're not just, you know, one department in the little pigeonhole, right, within a particular building. We really sort of bring about a larger array of interests and speakers on campus. Okay, so here's some other highlights as well, right, which I'm sure you're interested in with the particular students. We had, fairly recently, we had a class that was the chemistry of cooking, right? And so we were looking at, you know, what kind of chemical compositions were being incorporated within different, what's happening with chemistry in the cooking. So like with the creme brulee, right, what's happening at that surface, did a certain amount of sugar within that matter, and what kind of sugar, kind of things like that that we're looking at, not just the composition, but what's happening at the molecular level. And the same thing with like with the foods and cooking, what happens as you're cooking, what happens to the chemical makeup, the molecular makeup of those foods. So we have those kind of things happening. We also have students design their own projects, whether it be as a research project or within a class itself. For example, here, these three gentlemen, Matt, Adam, and Matt, we're looking at the content of different whiskeys. And so yes, they were all over 21, they were all seniors. And so what they were doing is they were analyzing how it is that you have the different whiskeys that say they have all the same percentage of alcohol. Why is it what's in each of them that makes one different from the other? And so they were analyzing it using analytical techniques that we have available within the department to analyze those different samples and come up with an assessment of what's making one taste different or have a different texture than others. And then also at the top here, it's sort of a group photo, is representative of what we do for our seniors. So this is our graduating class. And so as a senior, what we like to do is we like to take everyone out for lunch. And so on reading day, what we do is we take all of our Bachelor of Arts, Bachelor of Science, research students all to lunch at a local restaurant, and we grab a photo of it to remember. But this is what we do, and so we connect with each of our students, and many of us have a number of students in the different classes, not just as research students. So it's sort of like a hurrah, congratulations from the department at the end. So we have that as well. It's something to look forward to as you're there. I also wanted to point out too, here's an example of some other things that we do. This last year was the 150th anniversary of the periodic table. Maybe some of you celebrated yourself, but what we did is we celebrated it on Mole Day. So for those of you that may not know, Mole Day is in October, okay? And so it commemorates Avogadro's number. And so what we were able to do is we took over 118 faculty and staff and students, and we made a living periodic table. And so this was one image. If there's a link down here as well, it's also on the Roger Williams website as well. And so you can see us making this living periodic table, and we were able to take a picture of it. And so it's a way of us sort of doing some community building with chemistry. So it was one really very cool periodic table in the main quad at Roger Williams campus. So that was pretty cool. As some of you might also be interested, many questions often come about with where do your students go? What are they doing after Roger Williams? And so I tried to put together sort of a summary as to where our students have gone or where they are right now. So it depends on the student itself, right? So some students are interested in going on to graduate school, and so they can go to various graduate schools. And so these are some listed here that where our students have been successful, either going for a doctorate or as a master's degree. We also have students that go on after either getting their master's or right after having their bachelor's going on to the industry, right? So Pfizer, Amgen, those are the two more local ones that we've had students go on to, but others as well. They're listed here from Mystic Aquarium to the Broad Institute, Genzyme, the Department of Health for Rhode Island, and so various different aspects there. And it really depends on what kind of interests you have and how the research and the skill set that you have received from Roger Williams really makes you ready to be able to go on either to the graduate school or to your career path that you're looking for in industry. Okay. I want to also sort of leave you with some information here. This is the different faculty members that are involved within the department, right? So there's different persons you feel free to reach out to any of us. If you have any questions about the program, about research, how do you get involved, any of those things, I encourage you. And you can also get this from the website, the chemistry website as well, all these different contact information. But I highly encourage you to sort of reach out and ask whatever questions you may have. So if there's any questions now, please feel free. I can hopefully answer as best I can.
And again, you probably want to use the chat function. As a reminder, you can just put your cursor across the presentation. Menu will come up from the bottom. You can click on chat and ask a question from there. I know it always takes a couple seconds to get started, so no worries.
No worries. And I hope I touched on anything that you had questions about, but if there is anything you have questions about that I didn't touch on or I spoke too briefly about, please feel free to ask.
So we do have our first question here from Addison. What is the environmental chemistry program like? Do students go out and do research for this program?
Right, so we do have a environmental science program and we have an environmental chemistry program. So there's two sort of distinctions. Environmental science is a little bit more broad. So you have some bio classes, you'll have some other environmental type classes like sustainability and such like that. It's a little bit more broad. The environmental chemistry program itself is very similar to chemistry itself. So you have general chemistry, organic chemistry. You'll take environmental on top of the analytical and the instrumental. So it's the same sort of core classes. Let me bring those back up again. Same core classes, but you just have the environmental on top of that. And so it would be in your advanced class that you would take. The advanced class that you would take is the advanced environmental. So you would take the typical classes that you would for your Bachelor of Science in Chemistry, but you would then have Environmental Chem 1 and 2, or the Advanced Environmental as your advanced class. And that's how you would distinguish Environmental Chem from that of the typical, more broad chemistry degree. I hope that answers your question. Good.
Thank you, Addison. Next question comes from Elizabeth Ann. I would like to be on the pre-med track. Would biochemistry be the best to major in?
Okay, so at Roger Williams, we don't technically have a pre-med track or pre-dental, pre-vet, any of those tracks themselves. We do have advisors that can help advise you towards, a pre-med path, but we don't have tracks themselves. I know some other institutions do have that, but we don't have that. You may not know, but you can have, a degree in sociology or psychology and still become a MD. You have to take certain classes that are required for medical school. That's usually like the general biology and anatomy, physiology, biochemistry, and then general chemistry, organic chemistry are usually required as well. So as long as you have those type of classes, then you can go on to apply for medical school. With that said, most persons that go on to medical school have either a chemistry or a biology degree. That doesn't say that you have to, but it's more common. And so if you are interested in doing the pre-med, you can still be a chemistry degree. You don't have to do the biochemistry. You don't have, so you can, it's not cut and dry that it has to be biochemistry. If it's your interests, I highly encourage you to do that, but you don't have to. The biochemistry degree itself is probably one of the most credit-heavy majors because you're really taking all the Bachelor of Science chemistry classes on top of biology classes that are molecular-based. And so you would be taking as part of your degree the chemistry, right? All the ones that we have here, even on this particular slide. But you also would have the additional advanced course would be the advanced biochemistry. Then you also have to take like cellular biology, molecular biology, anatomy, physiology, those type of classes that would be for pre-med or for that medical school. So it may be possible, it would be something that would be needed to be known by an advisor very early on so that we could plan it out exactly when you're going to take this class, when you're going to take that other class. And so it just needs a lot of planning. But most likely, depending on your interest and where you come in, if it's biochemistry and that's your interest, then go for it. But you don't have to be biochemistry if you're going to go for medical school. I hope that answered your question.
Yes, we're getting the thumbs up.
Good, good.
I've got a second question here from Madison, but I want to get to the question here from Amanda. If I majored in biology or chemistry, some science, how much more school would I need to get a nursing degree after getting the bio or chem degree?
Oh, okay. So I have had students that have had either a bio degree or a chem degree and go on to be a nurse. Most recently, I can think of a student that went on to UConn. So usually you go for a master's after, so you can do biology or you can do chemistry. I don't know exactly what the requirements are for the nursing program that you would be interested in doing or going to, but usually it's general chemistry, organic chemistry, some biochemistry is required by nursing programs. For the biology side, it would be like the general biology, the anatomy, physiology, microbio would be required. I don't know what else might be required as well, but you could do a chemistry degree, a Bachelor of Science in Chemistry or a Bachelor of Arts in Chemistry, as well as a biology degree. And so you could do a dual major like that. If you feel like one would be more helpful than the other, or having both of them, you could do that. If that's helpful towards your nursing degree. But I really would need to see what nursing program you would be interested in, what the requirements are for that. But vast majority, it's organic in general for the chemistry, biochemistry, and then for the bio, it's usually the microbiome, the anatomy, physiology. But I would have to look at the nursing program itself. We don't have a nursing program at Roger Williams. It's just the chemistry, biology, biochemistry.
Very good. Let's go back to the second question from Addison. Will AP high school chemistry credits get you ahead in RWU's chemistry track?
Yes. So you have for the AP exam, right? You have to have transfer. I want to say you have to have 4 or 5, something like that. But it depends on whatever that grade is, that score that you have at the end. But I highly encourage everyone to take some sort of AP, even if you don't end up taking the test at the end. At least you have that experience, that exposure to the material that would be in your intro chemistry classes. But focus on the exam that you have coming. But we do accept AP transfer credit. And that could be that you could, depending upon what the overall score is, you could get out of or transfer in the credit for the general chemistry 1, or you could do for the full year. It depends on where you score. But yes, we do that.
And I know we also take, for anybody else who's a part of this, IB credit and A levels, although I don't think anybody here is an A level student right now. And we recognize that the AP test is going to be different this year, that it is a take-home test as opposed to, you'll be able to do it from home as opposed to the way that it's traditionally done. We're, especially on the admissions end, going to be extremely flexible with all of the testing, everybody's transcripts. Everybody is going through something, so remarkably different in this final term. Ultimately, we just want you to do your best, finish appropriately, and we're looking forward to everybody joining us in August. We do have one additional question here from Madeline. I'm going into RWU as an architecture major, but I'm interested in either minoring or majoring in physics. Do you get a lot of students combining these two?
Not very many. We do have a lot of students that are in architecture because physics is required. So we do have a lot of architecture students in that class. But as I said earlier, physics is brand new this year, right? And so we haven't had any majors before, right? So, but that would be an awesome combination between the two. Physics and architecture, right, really sort of tie together really well. And I think that would be very much encouraged.
Yes, one of the things that I can tell you, because I work in our department with quite a few architecture students, is architecture as a major itself is extremely demanding. There is a lot of work that you'll be doing outside of the classroom to be able to get your projects done. It doesn't mean that you're not able to have a major, a double major or a minor. It just means you have to work that much closer with your academic advisor to make sure that you're taking everything in the proper order to be able to finish with the degree that you're looking for and on time.
Right, and it also can get complicated too if you're really interested in trying to do both majors and you study abroad, right? So it's a lot of planning that needs to get done early on so that we can try and make sure that you get what you're wanting, or try and plan it out as best we can.
We do have one additional question. As a chem major, will I have to take all the classes currently listed on the screen, or are they all required unless listed as optional?
So as a Bachelor of Science, yes. Yes, you do. So the environmental chemistry here is only if you are an environmental chemistry major. But other than that, yes, you would be taking those classes. That's sort of the breakdown. In biochemistry, 2 is that advanced class. So you wouldn't have to take that, but physical chemistry, general, yes. So you're really getting the breadth of all the different disciplines, sub-disciplines within chemistry. If you're a Bachelor of Arts in chemistry, which actually we do have a number of them, a number of those also do secondary ed as a secondary education as their dual major. They don't have to take as many. So what they would do is take the general chemistry 1 and 2 and then 24 credits. So that ends up being 6 classes beyond that general chemistry. Usually that would be organic 1 and 2. So that's 2 classes there. Analytical instrumental, that's 4. And then they usually round it out with inorganic and biochem, but you could also do inorganic in physical chem. And so that's another way of getting the Bachelor of Arts. That works really well for those persons that are trying to do a dual major. And so sometimes if people realize that they want the chemistry major later in their career, or know that they want to do another major that's very demanding with credits and with time, the Bachelor of Arts in Chemistry is something that may be well suited to your schedule. And so that's where you may not have to take all these classes, but that allows still that bachelor's.
We have another question from Elizabeth Ann, and also related to a double major. I would like to double major in biochem and math. Would this be difficult if I were playing a sport?
It can be. So it depends on the schedule with the sport. We try and work with athletes as much as possible, but sometimes we have to have, there's only certain labs that are offered. Especially as you get higher up in the courses like analytical, instrumental, there's only 2 lab sections for those. And so it's usually we try and have them on Tuesdays. So if your sport has a number of different sessions or different games and they're often on Tuesday, that's gonna be really difficult. So we try and work around that as best as possible. If as a biochem major, it can be sometimes challenging because so many credits is required for that major. The math itself as well, having that in the biochemistry is going to be challenging to work around that. It's not that it can't be done, it's going to be challenging. With having that sport, it might be that you have have 2 options, let's say normally to take a particular class, and because of the sport, you can only take 1, right? And so you don't have, either, let's say the additional advanced course, right? And so your sport, let's say, is a spring sport, and you want to take the advanced class that's offered in the spring, but you can't based upon your sport. You might have to then say, well, I'm not going to be able to take it. I'm going to have to take, because I care about my sport, I'm going to do this other advanced class that's offered in the fall instead, even though that may not be exactly what what you may want to do. You might have to make some sort of concession in that way. It's just because of the number of offerings that we have and when they're offered. But we try and accommodate it as much as possible. I should also tell you that the biochemistry major itself, of the persons that we do have, that is between the chemistry, the Bachelor of Science Chemistry, the Bachelor Environmental, or in the Bachelor of Arts, the biochemistry is the least common dual major. And that's just because of the number of credits that are required for it, the number of classes that are required for it. It's not saying that you can't do it. It's just that if it would be requiring a lot of planning for those classes to be able to be done. If you're coming in with any sort of AP credit, Calc 1, maybe Calc 2, that would help as well to not only be counted towards your math major, but also would help with that. The math department also offers an applied math major. That might be something that's of interest, especially, and it might tie in really well with the biochem major. But some of those classes that you would take for the biochem may also count towards the applied math, if there's a certain math aspect to them. So that might be a way that we could sort of plan out that dual major. But without having it in front of me, actually, it would be really difficult to be able to tell exactly what those classes would be and what the plan would be. But it would be something that we could work out.
The other thing here too is as a Division III school, not all of some of our students will start off playing Division III sports, freshman, sophomore year, and then maybe back off a little bit, and kind of bump themselves down to intramural level, so that they don't necessarily have to get locked into a practice schedule that might conflict with an important class. And you're also able to kind of back off the travel schedule as well. Although our teams don't travel as extensively as, say, a Division I team would, we still play teams that are up in northern Massachusetts and western Mass, even southern New Hampshire. So some of the there is some travel involved with all of that. So there's different ways to be flexible on the athletic side as well. About roughly it's a little bit more than 50% of our students are athletically active on campus. So there's all kinds of different ways to be able to fold that in. And that's one of the wonderful things to think about the Roger Williams experience in general, is there's a lot of flexibility. So you haven't heard anybody say, no, you can't do anything yet.
We do try and do the best we can to accommodate you in your interests.
Does anybody else have any additional questions? I see Elizabeth Ann shaking her head no. Well, in that case, I'm going to give it about another 30 seconds, but I'll sign off here just to say, thank everybody for being a part of the session here today. Certainly, if you have any questions, I know that this particular session will be made available electronically. You'll be receiving more information on that. You can always reach out to the admissions department directly. You can feel free to call our direct number. Although nobody is in the building right now, it will ring in one of my colleagues' apartments. And we are answering email as we would if we were working full time. We're just doing it from home, and I'm sure that for Dr. Rossi as well, you're taking questions and emails as well. So feel free to reach out to any of us. I know the best questions usually come about a half hour after the session is over. So feel free to reach out to us virtually anytime.
Absolutely, absolutely. Thank you very much.
Thank you very much. Enjoy the rest of your afternoon. It looks like a great day here in New England.
Great, thank you.
All right, thank you.